Picture this. For over 13 billion years, the early universe kept its secrets locked away in darkness. Then, in 2021, humanity launched a telescope unlike any other, the James Webb Space Telescope. With its golden mirror unfolding like a cosmic flower, JWST promised to show us the universe's baby pictures. What it found instead was a cosmic revolution that's rewriting the very foundations of astronomy. Today, we're diving deep into the most shocking nature phenomena discovered in space galaxies that shouldn't exist, stars that formed impossibly fast, and black holes that break the rules of physics itself. When JWST released its first deep field image in July 2022, astronomers thought they were looking at a mistake. This tiny patch of sky, no bigger than a grain of sand held at arm's length, contained hundreds of galaxies. But these weren't the small, chaotic blobs scientists expected from the early universe. Instead, they found cosmic cities where there should have been villages. Massive, organized galaxies with spiral arms, bright cores, and complex structures that shouldn't have had time to form. It was like discovering skyscrapers in what you thought was an empty field. According to our best models, galaxies should grow slowly. After the Big Bang, it should take hundreds of millions of years for gas to cool, stars to form, and galaxies to organize themselves. But JWST showed galaxies that looked mature just 300, 400 million years after the universe began, like finding a fully grown oak tree in soil that was planted yesterday. The galaxy JADES GS13-0 exemplifies this cosmic puzzle. Formed less than 400 million years after the Big Bang, it shows signs of multiple generations of stars, heavy elements that take time to create, and the level of organization that challenges everything we thought we knew about cosmic evolution. In 2025, JWST shattered another record with the discovery of MOMZ-14, a galaxy that formed just 280 million years after the Big Bang. This cosmic powerhouse is compact yet incredibly massive, bursting with star formation at rates that seem impossible for such an early era. What makes MOMZ-14 truly remarkable is its chemical maturity. Instead of being pristine and metal-free, like first-generation galaxies should be, it shows signs of nitrogen and carbon elements that require multiple stellar generations to produce. It's like finding a sophisticated wine cellar in a house that was just built. Perhaps the most stunning discovery is Xulong, the torch-dragging galaxy. This elegant spiral galaxy, complete with sweeping arms and a central bulge, existed barely 1 billion years after the Big Bang. Spiral galaxies require time to stabilize. Their stars need to settle into orderly orbits, and density waves must shape their graceful arms. According to theory, this process should take several billion years. Yet Xulong had already assembled itself into a masterpiece of cosmic architecture in less than 1 billion years. It's comparable in size to our own Milky Way, holding an estimated 100 billion stars, all organized in perfect spirals when chaos should have reigned supreme. JWST is actively hunting for the universe's first stars, population 3 stars made purely from hydrogen and helium, with no heavy elements. These stellar pioneers lived fast and died young, exploding in ways that seeded the universe with the elements needed for planets and life. While we haven't directly spotted these stellar ghosts yet, JWST has found tantalizing clues, galaxies with extremely low metallicity and unusual light signatures that might be the fingerprints of these ancient stellar giants. One of the most perplexing phenomena JWST has revealed is the age problem. Many early galaxies appear to contain stars that look older than they should be. The light from these galaxies suggests they harbor stellar populations that should have taken over 1 billion years to form an age, yet they exist in a universe that was only a few hundred million years old. This cosmic contradiction forces us to question fundamental assumptions. Are our models of stellar evolution wrong? Is our understanding of cosmic expansion incomplete? Or are we witnessing something entirely new about how the early universe operated? JWST has discovered ultramassive black holes that shouldn't exist, cosmic monsters with masses billions of times greater than our Sun, existing just 400 million years after the Big Bang. These gravitational giants present a timing problem that challenges our understanding of black hole formation. To grow from stellar-sized black holes to these cosmic behemoths in such a short time would require feeding at rates beyond what physics allows. This has led to radical new theories. Perhaps these black holes form directly from massive gas clouds, or maybe they begin as primordial black holes created by quantum fluctuations in the very first moments after the Big Bang. These early supermassive black holes weren't just sitting quietly, they were actively shaping their environments. As quasars, they blazed with the light of billions of stars, heating surrounding gas, triggering or preventing star formation, and potentially acting as the primary drivers of early galaxy evolution. Perhaps most troubling for our cosmic models, some of JWST's galaxies show weak or missing dark matter signatures. These galaxies appear too organized, too stable, and too light to need the invisible scaffolding of dark matter that supposedly holds the universe together. This phenomenon challenges one of astronomy's fundamental pillars. Without dark matter, how do galaxies maintain their structure? Why don't they spin apart? JWST's observations are forcing scientists to consider radical alternatives, from modified gravity theories to entirely new forms of dark matter. All these discoveries are putting immense pressure on lambda CDM, our standard model of cosmology. While not completely broken, the model increasingly struggles to explain JWST's observations. The universe appears to have been more active, more organized, and more mature in its early years than our theories predicted. Scientists are now exploring modifications. Perhaps dark matter behaves differently than expected. Maybe star formation was more efficient in the early universe, or possibly our understanding of cosmic expansion needs revision. Some researchers are even considering more radical possibilities that our fundamental assumptions about the Big Bang itself might need adjustment. What makes these discoveries so profound is their consistency. We're not seeing isolated oddities, but patterns that suggest the early universe operated under different rules than we imagined. The cosmic phenomena JWST reveals paint a picture of a universe that hit the ground running, forming complex structures with breathtaking speed and efficiency. As JWST continues its observations, peering deeper into space and further back in time, we can expect more surprises. Each image brings new challenges to our understanding, new puzzles to solve, and new wonders to contemplate. The James Webb Space Telescope hasn't just given us better pictures of the cosmos, it's given us a fundamentally different universe, one that's stranger, more dynamic, and more mysterious than we ever dared imagine. The nature phenomena revealed by JWST remind us that the universe still holds profound secrets. In our cosmic backyard of 13.8 billion years of history, we've barely scratched the surface. What other impossible objects are waiting in the data? What other rules of physics might need rewriting? As we stand on the threshold of these discoveries, one thing is certain: the universe that JWST shows us is far more extraordinary than the one we thought we knew.